Here. Today is a day we get to celebrate medical students. And the Department of Peds annually tries to award one med student who's the outstanding medical student from the year that's graduating. And this year was really challenging because there's a bunch of fantastically and diversely talented medical students who are going to make us really proud, who are going to be pediatricians, and we're excited about that. We do have a group here of pediatric faculty that deliberated it was a challenging question, and we did, after looking at data and looking at evaluations, actually Antigone Kithas Kraft actually is our best med student of the year who's graduating. So you want to come on up? So Antigone's had a fairly interesting week. She finished classes. Second to last class was a wilderness survival class where she rappelled and camped for the first time. Thanks. So that was awesome. And then she finished classes. She got married, doing grand rounds, graduating, leaves for Cuba, and then leaves for Chicago. So she's going to the University of Chicago to finish her Peds. So please join me in celebrating Antigone and her work. All right, well, and now I think I would like to hand it, who's going to be all right, thank you. Nikki.
There's a lot going on back here. Hey, good morning. I'm Nikki Mihalopoulos, and for the last 5 years, Dr. Catherine Sherwin and I have had the pleasure of co-directing the pediatric course in mentored research for fourth-year medical students, and this is our last year, and we're going out with a bang, so I'm pretty excited about that. The course is going to evolve to better meet the needs of the students, especially with the recent creation of the accelerated program to a career in pediatrics. So the students who we typically get during fourth year are those who are starting their pediatric residencies in the middle of their fourth year. So that course will be evolving. So I was very pleased that the last cohort of this course was such a motivated and productive group of students. Antigone Kithas Kraft was one of them, and we're going to hear her talk about safety and how we can improve that. And then her husband of less than a week, Ira Kraft, is going to move to a very intellectually intensive, for me at least, discussion of genetics and interesting cancer. And he will explain that beautifully so that we all leave here with a much better understanding of that. And I just want to wish them all the best. They are both going to the University of Chicago. You just heard that Antigone will be doing a residency in pediatrics, and Ira will be doing a combined residency in internal medicine and pediatrics. And then after them, Maija Holsti will talk about the research programs that the department is doing for undergraduate students. Hey, Antigone, you are up.
Good morning, everyone. I'm Antigone Kraft. Thank you so much for having us today. Ira and I both have a lot of love for primary children, so we're excited to spend our last day as med students with you guys. I'm going to talk about a QI project that I've been working on with Dr. Rebecca Pertel for about a year regarding increasing adherence to a safe handoff structure. Can I move this? There we go. So let's talk about why handoffs matter. The number of hospitalized patients and providers involved in their care is continuing to grow, and inpatient care is becoming increasingly complex with complicated medical problems and large volumes of information that need to be communicated between multiple different providers. Communication breakdowns are estimated to cause contribute to 2/3 of serious patient safety events, and so a structured and standardized handoff is a way to facilitate quality communication between providers. I know we're all familiar with IPASS, but I wanted to refresh everyone on what IPASS actually stands for. I is illness severity, which is a quick way of telling the person receiving your sign out who's sick and who's not sick. P is patient summary, which is your standard one-liner. A, your action list, is your to-do list and your check boxes. The first S, situational awareness and contingency planning, is one of the most, is the if-then part of your sign-out, so it helps the person receiving sign-out know what to do. And then the last S, synthesis by receiver, is one of the most important parts of IPASS. This utilizes closed-loop communication and makes sure that everyone understands what needs to be done for the patient. The original IPASS study was published in 2014, and the utilization of the bundle decreased medical error rate by 23% and decreased the rate of preventable adverse events by 30% without having a negative effect on workflow. So this bundle was an excellent QI model because it decreased adverse events without impacting workflow. It didn't change the time spent on handoffs, didn't change time with patient-family contact, and didn't change computer time. So our mission was to improve patient safety by a consistent plan of care for hospitalized patients through increased adherence of a resident-structured handoff utilizing IPASS. And we aim to increase the entire IPASS structure to 50% use in pediatric residents during evening handoff. So once we came up with our aim, we brainstormed all of the reasons that there could be a lack of adherence to IPASS, and we came up with this fishbone diagram. So this is a fishbone diagram, and it's just a way to categorize different elements that we thought of into and think about how they contribute to the lack of adherence to IPASS. As you can see, it's a multifactorial issue, but the primary 6 overarching categories that we came up with were information, time and place, patient load, communication, competency, and chaos. And then within each of those elements, we came up with more details that related to them, all to culminate into the lack of adherence to the IPASS structured handoff. So again, to remind everyone, our aim was to increase the adherence to the entire IPASS structure to 50% use in pediatric residents during evening handoff. And after we made our fishbone diagram, we isolated secondary drivers that we felt we could feasibly intervene on to help increase the adherence. So the first primary driver was expectation, and this expectation is that all residents, utilize IPASS. And we felt we could intervene on this by observing sign out in person, providing training on utilizing IPASS, and continuing to remind residents of the expectation to use it. The next is culture, a culture that supports the IPASS bundle, which already exists here at Primary Children's. There are IPASS signs in all of the team rooms and IPASS lanyards that have been handed out, but we thought we could further intervene by providing coaching and direct feedback after watching sign out, and then having an IPASS-focused grand rounds. And then an environment that supports sign out was also very important to us, and we aimed to be able to find a regular place and time for sign out, as well as protected time. These are the tools that we used for our project. On your left, and I can't find there's the mouse. This is the evaluation form that we used. So for every team that was observed, we wrote down the name of the resident giving and receiving sign out, and then there's a reminder of IPASS in the middle of the page. And then the bottom of the page, each number would represent a patient being signed out, and we would check off the elements of IPASS that were used for the sign out of that patient. And then on your right is the feedback form that was used and given to residents immediately following sign out with their initials on the top, and then under the plus sign, I just wrote an example of a good use of IPASS that the residents would use. So we would make note of the elements that they always included, and then underneath the triangle was our suggestions for feedback. So we would note how many times they used an element if it wasn't 100% of the time, and give suggestions for improvement. So this is a run chart of all of the data that we collected during our study. It's resident adherence to IPASS. On your y-axis is percent adherence, and your x-axis is the weeks of the study. At the very top of the graph, there's a blue arrow that says pre and an orange arrow that says post. The blue arrow represents the time before any of our PDSA cycles, and the orange arrow represents all of the time after, which will be important for graphs to come. The blue dots on the bottom represent the adherence to IPASS every week, and you'll note that there are some zeros. This is because our scoring of the utilization of IPASS was binary. Either they utilized all of IPASS or they didn't. So even if a resident used 4 out of the 5 elements of the IPASS bundle, they still received a score of 0. Our aim was to increase the utilization of IPASS to 50%, so I drew that line just to show you that we did not achieve that goal. And then the green arrows show the 4 PDSA cycles that we implemented. Cycle 1 was direct feedback, 2 was improved IPASS training, 3 was reminders of the expectation to use IPASS, and 4 was the IPASS-focused grand rounds. Before any of the interventions on the red line, you can see that our percent adherence to IPASS was 5%, but you can see that it did increase to 16% after all of our interventions, and you can see that individual increases in the adherence to IPASS, especially after the grand rounds. So this graph shows adherence to each element of IPASS. Your x-axis shows percent adherence, and your y-axis is the blue and the orange from the arrows in the first graph, showing adherence pre-intervention and post-intervention. Our overall goal of adhering 50% to IPASS was not achieved, but we did note that there was a significant increase in adherence to each element of IPASS. There are 4 elements that we did see a significant increase on, and those are I, P, and the 2 S's. And as you can see, there was already a significant amount of adherence to A, which is action list. In the original IPASS study, after the bundle was introduced, the adherence to each element of IPASS was between 50 and 80%. And so you can see that here at Primary Children's, we're within that range for 3 of the areas. Where we're a little bit lower is I, which is illness severity, and S, the last S, which is synthesis by receiver, which Dr. Patel and I felt are 2 of the most important parts of IPASS and areas that we could definitely improve on. This is a graph that shows our balancing measure, which was time per patient handoff. There was a little bit of an increase in time per patient handoff after we implemented the PDSA cycles, but it wasn't statistically significant. So things that we learned. We learned that changing the culture surrounding handoff is challenging, and that makes changing the environment challenging. So environmental barriers that we learned about and were definitely faced with when we observed sign out are pagers and pages going off and phone calls being made, different people coming in and out of the room, and the actual space for sign out itself. So looking ahead, it's important to remember that change is difficult, and being aware of barriers is also really important because that's the first step in making change. But keeping patient safety at the heart of what we do is what we all want, and it's a common goal. So by having cultural awareness and being aware of the barriers that we're facing, having a space free of non-emergent distractions, and altering training surrounding IPASS in a way that learners and users of IPASS are more receptive to are ways we think we can improve the adherence. And Dr. Patel has already done some work on altering the training of IPASS and has linked the lack of adherence to the lack of autonomy that comes with a structured and standardized handoff. So working with the users of IPASS to make their learning more effective to them and more relevant is a way that she's currently thinking about improving it right now. And then always continuing to encourage a culture that supports structured handoff and patient safety. I have a lot of people to thank. Dr. Patel, who was the leading investigator on this study, Tanner Trujillo, who helped us with our statistics, and then Nikki Michalopoulos, Catherine Sherwin, and Maija Holsti, who ran the research program I was a part of this year, Dr. Good for all of his mentorship and work on IPASS, and then specifically Dr. Irene Kikolas and Nikki Michalopoulos have been personal mentors of mine since I was a third-year med student and helped me apply for residency, interview, and figure out everything, and are part of the reason that I chose to be a pediatrician. And then lastly, my husband of 5 days, who was a great practice audience for me and is going to be your next presenter. And I will happily take any questions. Oh, and my brother, Andrew Kithas, who has dealt with me for many years and is sitting in the back.
Questions for Dr. Kraft? Tomorrow, Dr.
Tomorrow.
Kraft. But in our eyes, you're Dr. Kraft.
Oh.
Any questions?
Hi.
Barriers you think are easily fixable? And
I think easily is a hard term because it depends on who.
how would you rank them? What would be the tier?
One of the barriers I think that Dr. Pertel and I have thought about in terms of the environment of sign out would be sort of treating sign out like a noon conference where senior residents would hold the pager for a designated time of 30 minutes. Nurses would know to hold non-urgent pages, and the ER could hold non-urgent admissions for a designated period of time. I think that would be a really easy systemic way to help improve sign out.
Thanks for a great presentation.
Oh, thank you.
So, just to follow up sort of to Bruce's question. So if you had to pick the next intervention test, what would it be?
I think I would work on improving training for IPASS. I haven't been personally involved in the training for it, but I was the person who worked through the reminders of the expectations for IPASS. I think it would be great to sit down with the residents who use it every day and figure out what part of it isn't effective for them in order to make it a more efficient process.
Very well done.
Thank you.
You talked about feedback, and you're a med student, and you were giving feedback to interns, right? How'd it go?
Oh, I think it went fine. I've worked with a lot of the interns personally because I did a sub-I here, and I've tried to do every rotation possible working with kids. So they were really receptive to it. All the residents were really friendly when I was in the room watching sign out.
I wouldn't mess with her.
So IPASS is a pretty cool acronym, but maybe it's only the P, the A, and the second S that matter. Do you have any idea about how our residents performed, how that correlated to reduction in error events or safety?
I don't have any data on the correlation to safety events from our personal study. That's definitely a next step for Dr. Pertel and I. So I don't have that data.
I think that's our serious safety events are, the absolute numbers of them are pretty low. So you could try to link it to precursor safety events, but we don't really have that data yet.
No, I do know that, oh, sorry.
If we can stop having SSEs, then we can actually look at our PSEs.
I do know that our residents, in terms of the adherence to IPASS, are pretty much at the national level, especially for all of the different institutions that were in the original study.
Ira, you're on.
Okay, so now for something totally irrelevant. So my project is titled Beyond the Triad, Exploring Tumorigenesis in Multiple Endocrine Neoplasia 2B. And importantly, this is actually a project that I was able to start in 2016 on a research year, and then was allowed to continue it throughout this year with a partnership at the NIH under Brigitte Wiedemann, Jack Shern, and John Glod. So importantly, what is MEN2? And so MEN2 comes in two flavors, and as a med student, we learn that MEN2A and 2B are these two different cancer predisposition syndromes that comprise of very specific tumors. MEN2A being tumors of the parathyroid gland, the adrenal glands called pheochromocytoma, and medullary thyroid cancer, whereas MEN2B is comprised of mucosal neuromas, pheochromocytomas, and medullary thyroid cancer. This was about all I knew when I started this project, and of course very quickly learned that actually both of these cancer predisposition syndromes are caused by mutations in the same gene. And that occurs, mouse here, that's okay. So that occurs for MEN2A, the mutations occur in this area of the gene that actually sits outside of the cell called the cis domain. And in MEN2B, the mutations occur in the area of the gene that sits inside of the cell, and both allow for signaling independent of having an extracellular ligand. Additionally, the first thing I did when I got to the NIH looking at this is I wanted to know what the lifespan of these patients were in general, because again, this is something that in medical school we all have to learn about, and I actually found out that these patients only live to be about 22.6 years old. And the reason for that is because they have metastatic medullary thyroid cancer from birth, even before thyroidectomy. And so that's shown in this example of a patient here that had a lymph node metastasis in the groin, and another which had a prostate metastasis. And again, these sort of develop over time. So what we were able to do is looking at patients that develop disease over time and took samples of different parts, different tumors. So starting with a patient that we saw at the NIH had lymph nodes, so we were able to get germline tissue. Then they developed their primary medullary thyroid cancer. Then after that, developed a lesion in their prostate. And after that, a lesion that was a metastasis to the skin. And importantly, when a pathologist reviewed these, they were all histologically identical to medullary thyroid cancer and stained positive for calcitonin. So what we decided to do was, looking at a group of patients, we isolated DNA from these pathology samples and reviewed their clinical characteristics, did whole genome and whole exome sequencing on the samples, brought that data back and connected it with their clinical characteristics to create these genomic timelines of when events occurred in this disease pathogenesis. So in order to understand some of the data that I'm going to present, we have to review genomics a little bit. So I'm assuming everybody in this room knows that our genome is composed of 4 different base pairs, A, T, C, and G. And again, that's about all I knew when I started this. But when you get a next generation sequencing panel on your patients, you actually get a lot more information than just the sequence of the DNA. So the first thing you get is if a patient has a single nucleotide variant. And so that means that one of those base pairs is replaced with another one in a location where it's supposed to be. So for this example, a T got replaced with a C. The next thing you would get is the variant allele fraction. And so this is the amount of times that that C appears instead of a T. So for this example, the C appeared 49% of the time and the T appeared 51% of the time. Lastly is the depth of coverage. And now this is the amount of times that your DNA sequencer read the DNA strand. And so in this case, it read it 187 times. And it's important to note that the sequence was read both forwards and backwards, so that we can remove any errors from DNA sequencing. So when we put all of this together, this example would be a heterozygous, so a 50% change in a T to C single nucleotide variant, and this one happened to be in the RET gene, which causes the M918 missense mutation, and it was read with a depth of 187 times. And I know I went really fast with that, and so we're actually going to revisit this concept a couple more times before we get to the data. So for single nucleotide variants, we actually had 2 different patients that we were able to analyze tumor samples from, and for this case, we're going to call them Han and Chewy. So for Han, we were able to get whole exome sequencing, and that comprises of about 2% of the genome and is the DNA that codes for proteins. For Chewy, I was able to actually get whole genome sequencing, which is about 3.2 billion data points. And then we were able to analyze this in 2 different ways. One with the germline single nucleotide variants. So these are the variants that are in every cell in the body. And the other way was with the somatic single nucleotide variants. And so these were only the variants that are present in tumor cells, but not in every other cell of the body. Next, looking at the variant allele frequency, I wanted to show you this by an example of a group of cells here. And so each cell is a circle, and each of the lines are the 2 pieces of DNA in each cell. And so if you have a wild type cluster of cells or a tumor, that group of cells will have a variant allele frequency of 0 because there's no mutations in it. Whereas if you have a mutation on both strands of DNA in every cell, that would be a homozygous mutation, and that would have a variant allele frequency of 1. Similarly, if you have a mutation on one piece of DNA on every cell, that would have a variant allele frequency of 0.5. where it gets a little bit tricky is when you have clones and subclones in your set. And so for this example, the blue dot would be a mutation, and that only occurred in about a quarter of the DNA present. And then when we add this up with all the other mutations, we get a range. And so each variant actually has a range with a different variant allele frequency. Now, if that's not enough, the DNA that we measure in next generation sequencing also, we don't get the same amount of DNA from each area of the genome. And this is the copy number. So in this case, in this region of the DNA, we see that it got read about 6 times by the sequencer. This area it got read about 9 times. This area 3 times. And so when we analyze this, we actually find out that this first area is 2N, so that would be 2 copies of DNA. Next area would be 3N, so 3 copies, and the next area is 1N, meaning 1 copy of DNA. So the next graph I'm going to show you is actually what this whole genome and whole exome sequencing looks like. And so as you can see, it's a huge amount of data points. And so what I'm showing you here is the graphs for Han and Chewy. On the x-axis is the germline variant allele frequency, and on the y-axis is the variant allele frequency of tumors. And as I'm going to scroll through, you're going to see changes in the single nucleotide variants as we track them from tumor to tumor. Okay, and it's important to know you get a cluster. So, for example, let's see, where is? Okay, so in Han, you see this cluster right in the middle of the graph is going to be your heterozygous single nucleotide variants, and this cluster is the homozygous single nucleotide variants. And again, it's important to remember that these are different kinds of sequencing, because this was the whole genome, so 3.2 billion base pairs, whereas this is whole exome. So as we scroll through, we actually see, so the first graph here is showing the primary medullary thyroid cancer on the y-axis. Then we get the prostate lesion, and I want you to note this area that's highlighted by the red box, because you can see that in the samples from Han, as we move to another metastasis, the skin metastasis later in time, we're seeing a group of single nucleotide variants that are moving from the center of the screen up to the top. And what that is representative of is a loss of heterozygosity. So we actually are able to find the center of that cluster of single nucleotide variants and trace them. So again, from the patient's germline to their primary cancer, to then their prostate lesion, to the skin lesion afterwards. Whereas we don't see this with Chewy. So next, we looked at this with in terms of the copy number changes. And so this graph works where on the x-axis we have the whole genome, starting from chromosome 1, ending at chromosome X and Y. And then on the y-axis is the amount of DNA all across the genome. And so in this case, we can look, and this is the primary medullary thyroid cancer, and you can see that for Han, the cancer looks pretty uniform. So there's 2 copies of the DNA all the way throughout, and importantly, you can see that there's only 1 X chromosome, so Han is indeed male. For Chewy, we have a little bit more variability. We've lost a copy of chromosome 1 and a copy of chromosome 4, but otherwise it's pretty stable across. When we track this to the prostate lesion, we see that in Han we've changed, some of the DNA copy numbers have changed throughout the chromosome. And in Chewy, again, the chromosome is fairly stable. We've lost part of chromosome 1, but importantly, chromosome 4 is there entirely. In Han, with the skin lesion, we're able to actually track these changes again, showing that these changes are recapitulated once more in a later metastasis. So one of the most important findings from this was that the presence of chromosome 4 in this prostate lesion for the sample from Chewy, whereas in the medullary thyroid cancer lesion, we actually we're missing an entire branch of chromosome 4. So this represents, implies that the lesion for the prostate actually couldn't be a metastasis from the primary medullary thyroid cancer. Really quickly, we used a bunch of other really fancy genomic tools to look at this, including unsupervised hierarchical clustering, bootstrap analysis, and these two other tools called Cyclone and Clonivol, which I just wanted to include because it had a spinning graph. So really, the moral of the story is that actually for multiple endocrine neoplasia 2B, we have two different mechanisms of tumorigenesis in this disease. The first being that patients are born with the cancer predisposition syndrome with this RET mutation. They develop primary medullary thyroid cancer, which gains a metastatic potential and then becomes metastasizes to different sites, including the skin and the prostate. Whereas in Chewy, we have a similar precancer disposition syndrome, which then is able to evolve into independently a prostate lesion, which is not a metastasis of the primary medullary thyroid cancer as previously thought. So, revisiting what we learned in medical school is that for MEN2B, we can actually now characterize this as having mucosal neuromas, pheochromocytomas, medullary thyroid cancer, and add a base to this pyramid, including the prostate. So with that, this work has involved a huge amount of people from MD Anderson, from the NIH, from NYU. I need to thank Brigitte Wiedemann. She's been an incredible mentor. John Glaude, Jack Schern. And of course, this year, Nikki, Catherine Sherwin, Maija, and Irene have been just absolutely incredible mentors, and it's been fantastic. And of course, Antigone, my new wife, which is weird to say. So these are some of the people at the NIH. In the middle is Brigitte. On the right is John Glaude, and then the group that I was in is with Jack Schern and his two postdocs. So with that, I will take any other questions. And Antigone and I really wanted to note that these are both Irene and Nikki's daughters, who are both flower girls in our wedding.
Any questions for the young Dr. Kraft? 10. Tomorrow. If you think saying your wife is weird, wait till people start calling you doctor. You're going to like be looking around for Any questions? I think you need a nice young brain to understand this stuff. Holy cow.
Like,
Sorry, I just want to make sure our online people can hear. That's why.
thank you. Very well done. What does this mean for therapies? Are they trying to think about changes?
So we actually, this is under review right now in Journal of Clinical Oncology. And one of the things that we've been postulating a lot is whether these patients need prophylactic thyroidectomies. And one of the pieces that I did not include in this was actually how prevalent this is. And it's actually in about 30 to 40% of patients. So at this point, there's no prospective studies showing whether or not these cause long-term effects. And so we don't recommend doing anything other than watching it. But of those patients that we've reviewed, 3 of them have had their prostates removed. Thank you.
Maija, as I was getting ready this morning for today, I thought, my great friend Maija is speaking. I don't get to introduce my good friends that often. I was also thinking the first time I met you, Axel, her oldest, was this little tiny baby, like about 6 weeks old maybe?
Oh, tiny.
In this little carrier. And I remember you coming we had a lunch, And he's now driving, I hear.
As of a week ago.
It has been a great 16 years, and Maija's going to talk to us about her great academic associate program.
Thank you, Joyce, and thank you. Wonderful presentations, and good luck to both of you. And I hope you continue on as a physician scientist and have a wonderful career in research and in medicine. One of the things that I want to talk about is this continuation of fostering and mentoring physician scientists, but actually stepping back and doing this at an earlier time. And I'm going to talk about the Academic Associate Program, which is a Department of Pediatrics program that I helped start. Just as a background, I am a pediatric emergency medicine physician, and when I was interviewing at CHOP in Philadelphia, they had a similar program like this, and I became very intrigued by it, and always had it in the back of my mind as a fellow, and when I became attending, I was interested, our division chief was interested in starting a program like this, and I went to Carrie Byington and told her about it, and she helped support the startup costs that it took to do this program. And one of the things that I think is very interesting too is that this is a win-win for a lot of people. This program, when I look at it, I want to provide experiences for students for shadowing, for leadership, for research, and for patient exposure. And if you interview for medical school, we know that we need all of those things as we go to medical school. And then we also want to provide experiences and also support to our researchers in the department. And so this is the idea of what I'm trying to integrate, those two concepts. And so everybody wins. And so, and it's developed throughout the years. So the Academic Associate Program is also known as the Blue Coat Program, hence the blue coats. We have a light shade and a dark shade. The light shade are our junior blue coats or research assistants, and the dark blue coats are our more senior students. So our objectives is to teach students about the fundamentals of clinical research and really get them an opportunity to conduct real-time clinical research in the clinical environment, learn how to interact with patients, families, and the medical team in busy clinical environments such as the emergency room, and establish relationships with physicians, nurses, and technicians so they can see early on, is this a career that I want to do? Is this something I want to do later on in life? And how can I integrate research if I would like to do this as be a physician scientist? And then obtain a pediatric clinical research minor and help obtain skills that prepare them for graduate school of any kind, from nursing, PA, medical school, and also employment. And then from the researcher's perspective, we want them to have access to research assistance for prospective studies, and that you don't need to have a lot of money in order to do those, and that it increases their feasibility of doing simple prospective clinical trials here. This is our office, myself, Judith Neugebauer, who is our manager, Sarah Barth, Rachel Lavering, and Amy Klein, her in the back, and Brooke Adams is our research assistant. So we have a number of program coordinators that help run a lot of our programs in our office, and it's a team approach, and they help support this program. Brooke is our administrative assistant, and she's a graduate from our program that we recently hired. We also have a student leadership team. We have a chief, a vice chief. These are paid positions that are partly supported by grants through the main campus at the University of Utah, and they are in charge of helping scheduling, weekly grades, and problem solving with students, which there are many at that age. And then the vice chief is really our liaison between our researchers. And so to try to make sure that we are communicating with them well and that we have a good communication between research studies and our researchers. And then we have a PR representative to help advertise our program throughout main campus, as well as 6 lead trainers that help train them, and a lead scribe trainer, which I'll explain in a little bit. This is our pediatric clinical minor degree. In order to get a minor, you need 16 credits. And when I went to apply for the minor degree, one of the benefits of this is that we're giving our students
a skill to be employed when they're done from undergrad. And a lot of times I've heard people say they've spent 4 years in college and they're still waiting tables. This is a skill that they are employable, and we can help get them some jobs that are in the interest of where they want to go. So I'm going to step back and just describe the course a bit, and I'll spend a little bit more time talking about our introductory course. Some of the things that we need to do is get our students up to speed quickly and very intensively in the beginning of the semester. So we ask all our undergraduate students to spend the whole day Friday before classes start as an 8-hour orientation. We have training weeks, we have weekly class lectures, and then of course our clinical shifts. Our 8-hour orientation is the Friday before the semester. We go over the syllabus, expectations. We have a lot of scheduling things. So we schedule our shifts from 6 in the morning until midnight, 7 days a week, almost 365 days a year. So there's a lot of scheduling things that they have to learn. We have to teach them how to screen and log when you're screening patients in the hospital and the ER. We give them informed consent training, and we do a mock consent during our orientation. And then I give a discussion about professionalism. How is working in the emergency department of the hospital different than your job at Starbucks? There are some differences. There's some similarities and there's some differences, but really kind of hone in on professionalism and what it means to be a patient and how to interact with those patients, and really step back and let's think about this when we before we go into the hospital. This is not fun and games. This is the big league. This is a little different level. And then we have clinical study presentations from all our principal investigators and our research assistants. These are some examples of our recent studies that we've done. We represent not just the emergency department, pediatric infectious disease. We have a study that's going on in the PICU. Our THAPCA study, our students help with patients and that were involved with that study. Behavioral health study is a psychiatry study. We have a concussion study that's being done in physical medicine and rehab. So there's a number of divisions that are involved, and we try to accommodate everybody's needs. This is the cliff notes of our program. So you imagine when you're a student and you're responsible for 8 to 13 studies, you're not going to remember all the details. We ask our researchers to accommodate us and put them into a flip book that is easily accessible so they know where to find the information about the details of enrollment. So this is our studies for this semester, for the summer. We have 8 studies. We've had up to 13. We have them get sort of a little bit of a priority on what are the studies that are a little bit rarer to find patients, and whether the studies that you could enroll 50 in a day, and so on. So we give them some guidance on how to do this. Every study has these 2 pages. So we have, this is an example of behavioral health outpatient study. We have a study purpose at the top, and then the talking points on the consent, just to orient them so they get a feel before they go in and talk to families about this. And then on the left, who to call if they have problems, what are our inclusion, exclusion criteria, and a stepwise approach, like a recipe in a cookbook that literally tells them every step that they need to do. If it's not there, I tell my researchers it's not going to get done, because we can't expect them to remember all those things together. Here's a biosignature study that is being done by Dr. Eric Glissmeyer, and this is a little bit more involved, where you have to get forms from physicians, forms from the parent. We have to get samples, work with nurses, and so on. Again, the talking points on the consent to help them orient them, and then exclusion criteria, and a stepwise approach. So all our studies are in these flip books, and they carry them around so they have them easily accessible to orient them before they get into the room. We also have training weeks for the first 2 weeks. So the orientation's 8 hours. Then we have intensive training weeks where our senior students are training the junior students. So we have near-peer mentorship, and they really go through a checklist. This is where the bathroom is. This is how you do Icentra. So they really are trying to figure out how to orient themselves in the hospital to who is an attending, what is an attending, who is a resident, and really compare, show them all these things. So we have a standardized checklist, and we begin enrolling patients into studies during these training weeks and help support them. So we have them monitored for those first 2 weeks. On the first day of class, we have a mock consent and assent exam, so parental permission. We got this, we just finished this on Tuesday, and we had 17 clinical trials office research coordinators as well as coordinators in our emergency room to do one-on-one training. This is not meant to, you do or die. This is meant to empower them on how to consent. We need to make sure they go through the 8 elements of consent and that families feel comfortable and that feel that they know how to read through the consent form. And so we have them practice those, and they went through 3 or 4 studies with each coordinator. And if there's any problems, we provide more assistance. This is, again, not meant to be failure. This is meant to be supportive, and we want them to feel empowered and confident. And then also in the first 2 weeks, we have them do a closed book exam just on what is the research that they're doing, so they're able to describe it. If Dr. Clark sees them in the elevator and says, okay, tell me about the biosignature study, that they can tell them a little bit about what they're doing. And then an open book study, that exam, where they look at PowerPoints on Canvas, they look at their flip book, and it teaches them how to find answers to the questions that they might need in order to enroll. So they know where to find that information. As far as their educational aspects that we're training them, they all have to be HIPAA trained, city trained. We have weekly classes where we talk about consent, assent, good clinical practice, ethics of clinical medicine or clinical research, study design. They learn how to design studies. They do a journal club where we have researchers give us examples of articles that are associated with their research, and they learn how to present in a journal club and with that. And so this is all part of their clinical research training. They do, as part of their class, they do 2 3-hour shifts a week for 4 credits, and they can do up to 4 3-hour shifts for 6 credits. They screen and identify, and when I had a study going on in the neurology clinic, it's expensive to have someone sit there for hours and waiting for 5 hours to enroll 1 patient. So they're there screening, looking at iCentra, trying to identify patients that could be eligible for studies. They do informed consent and assent. They collect data from physicians, from parents. They actually are videotaping in a concussion study, a balance test for our patients that have had head injuries. They learn how to submit the forms in a very good way and good clinical practice. They handle specimens, and they sometimes do telephone follow-up. This is an example of our closet in the emergency department that is converted to an office. They keep all their supplies there. They have a computer there. They have a telephone there. They can put their bags there and so on. So this is right around the corner in Pod 1, and I tell them this is probably the highest real estate office in the building. So take care of it. 5902 is, again, a continuation of being a research assistant. They also continue to have other class lectures related to research studies, and these students take a leadership role and help train our new students. These students also earn University of Utah IRB Human Subjects Research Training Certificate, the RATS classes offered through the Office of Research Education, and they're helpful in piloting new studies that might be going on with our researchers. Our 5902 is clinical research in medicine. Again, they continue on as a research assistant. In order to apply for this, they have to have a B- or higher. And they also do a physician extender shift, which I'll talk about in just a second. They attend lectures related to research studies, and again, they also help train our new students. And these are the dark blue coats that we showed earlier. Our physician extenders work with us side by side in the emergency department. They help with patient flow, communication, and they help scribe. And so right now we're in the process of helping our physicians. When we go into the room with a mobile computer, they will type down the history while we talk to the family. So we're not sitting here typing and trying to talk to the family. And so they help enter in data in the history for us. They assist again with communication, and they also provide comfort measures. Do they want something to drink? Do they need a warm blanket? They check on it. We have these stop clocks now in every single room where we're trying to round on our patients every hour, so they're not being left in the room for 2 or 3 hours with no communication. And so they'll stop in and round on our patients and say, is everything okay? Can I help you with anything? In order to assist that we're still here, we still know you're here, and we still are trying to communicate with you and let you know why you're waiting, which is really what families want to know, is why are we waiting so long? And then they help follow up with test results. They let us know when things are back, so we are more timely with moving patients through. Our elective part of our minor is students can attend research in progress online and in person. They also complete the research administration training series or the RATS modules in line with that as well. And so by the end of this, if you do get a minor degree, we provide a certificate for them that shows all the trainings, the HIPAA City training. It tracks all the hours that they worked as a research assistant, and they are set up for the research coordinator exam. They just need a few more hours with their RATS modules and the RATS training certificate. So they're well on their way to being a research assistant if that's what they would like to do for a short period of time or for a career. And many of our students have been able to get research assistant positions in the department as well as the university. So just a little bit about our impact. These are the places that we've served, that we are housed in the emergency department, but that does not mean that they can't go upstairs and help with inpatient studies, just as a plug. We are in the pediatric intensive care unit. We did the THAPCA trial and helped with that, and they're doing a survey this semester in the ICU with one of the pediatric ICU fellows. We've even been in labor and delivery, and let me tell you, what an experience for them to basically consent and enroll patients for an STD trial with a laboring mother, and we were able to do it. So they had many stories about that, but it was great for them. I mean, you got to let them go. We provided a lot of assistance, a lot of hand-holding, but they were able to do this. They rose to the occasion and would run over there when there was a laboring mother across the bridge and help enrollment. We've also been in HEMONC, cardiology, the rapid treatment unit, and inpatient. We've had almost 550 students complete the program, and about 100 of them have actually gotten the minor degree. 60 of those have been accepted to medical school, and 40 to graduate school, and 56 of them have been employed as a research assistant or a coordinator. We've had 58 studies since 2009. 18 have been published. This data is a little bit behind. We try to track this, and we're in the process of updating that. But we track all the studies and where they are in publication as well. These are some of the examples of some of the publications that we have throughout the years. And some of them have been published in JAMA and the New England Journal of Medicine. So, just a couple quotes from our students. This course gave me an excellent insight into the clinical and research aspects of the medical profession. One of the classes I participated in during undergraduate and graduate school, academic associates, had the single biggest positive impact of my career trajectory. The experiences I had as an academic associate program were some of the most valuable in my education. And just as an aside, I had a couple students that participated in my program that realized that medicine was not for them. And that is a service. And I'm just going to back up Chris Stockman, who was a big researcher in our department, who passed away. But he wanted to do the MD, PhD program. And when he participated in our program, he realized, you know what, I just want to do the PhD part of it. So this is a program that really helps students understand, is this what I want to do for the rest of my life? I've had students say, I do not want to ever see patients in the rest of my life, and I'm going to business school. Thank you very much. And that's important. We need to let them have these experiences. As an interviewer from medical school, I did run across some people that said when they were trying to get shadowing experiences that they opened the telephone book and they went down the line and just called people. And they really had a hard time getting shadow experiences. They're really having a hard time getting patient exposure or leadership or research, clinical research opportunities. And so we want to provide that. So for researchers, they have the benefits of this is they have access to research assistance that's really low cost. It increases the feasibility of doing these simple prospective clinical trials. And for students, they gain research experience. They get to work in the clinical environment, really figure out what they want to do and get those experiences. This is what I want to spend the rest of my life doing because it's a lot of hours and it's a lot of training. So you better figure that out soon. And they establish relationships with physicians, nurses, and technicians as mentors as they go through that process. If you're interested in using this program, we have on the Department of Pediatrics, we do have a website that talks a little bit about this, as well as meeting with one of our program coordinators, Sarah Barth, Rachel, who's in the back, and Amy Klein, who's in the back. And we have you help us. We have a lot of materials that we ask from you in order to make this a success. We ask you to pilot the study with our leadership team. The $550 a semester, it's actually a trimester because we do it summer, winter, and fall, is really money that's set aside to hire students at breaks, okay? So we get tuition dollars to help to support the cost of this program, which is helpful, but the $550 will hire them during summer breaks, winter, Christmas breaks, Thanksgiving, spring break, fall break. There's a lot of breaks in college. And so we hire them so we can continue to keep these studies going because and a lot of students are actually looking for work during the breaks. We ask you to present at orientation and maybe do a lecture during the semester. Provide us a PowerPoint so we can have some educational things online for Canvas as educational and teaching purposes. We ask you to work with us within our flipbook and make your study fit into our template, give us our parental permission to send forms, provide articles and questions that we can use to quiz them about your study, and then provide any other checklist materials, keep those updated in the office, and then be available. I do not want to get calls about a research study that I don't know as much about. I want somebody in your office to be available if they have questions so they can feel that. I think that having an in-between communication sometimes causes error. So I'd like to thank the Department of Pediatrics, the University of Utah, Clinical Trials Office, and then the Primary Children's Hospital Administration, as well as the office. I couldn't do it without all the great people that I get a chance to work with every day to make this successful, because it is a team approach, and it's certainly not just me. The students are very involved. They're very empowered by this, as well as our office, and so that I would like to provide thanks to everybody else, and thanks for the opportunity to present today.
Questions for Maija?
I have a question, but I just want to say thanks. If we use this as a recruiting tool for our residency to show just the process and the education, the longitudinal education that we provide here at the U.
Yeah, and our fellows, our fellow recruiting, because when I was a fellow, I sat in the ER every day trying to enroll patients in my studies. You know, I didn't have someone to do that, to help me do that. So, but with that comes responsibility. All those things that, you know, that Maija asked of the researchers, and they need to really be held accountable for that as well.
Just another plug, like QI projects that are done. I just got an email from David Chalk, and we're going to do a QI project in the emergency department. So it doesn't always have to be research, but they're going to do a survey on all our patients that are being discharged. And so that can be helpful as well. And so they're there. They want to work, and they're definitely more happy when they're involved and get to see more.
I can't believe that with your background that you don't talk about the colors in our introduction, and we go through that. I either say Carolina blue.
No, it's Duke blue. So remember, the senior people are Duke blue. I grew up in Chapel Hill. I'm a light blue and a Duke blue. I went to UNC Medical School and Duke undergrad, so there you go. That's a representation of the colors there. Well, thank you very much. I appreciate your time, and congratulations to our students. I hope you continue on. We need physician scientists, and this is an opportunity, the Mentored Student Program that Nikki has been running, as well as this program helps us continue to support and mentor our students that are interested in research. Thank you.